Please read the following problem. Stop the video now and read the problem. So now look in the graph. Let me comment the graph. I can see that the three objects that they are moving, one, the graph of x of t is this one, etc. They are having the same position at the same time. So the starting point A is that they occupy the same position xa at the time ta. Perfect. But there is a difference. At the point A, the similarity is that they have the same position. But the object A, the object 1, the red one, have a negative slope. And the slope of the graph in a xt graph is the velocity, is delta x divided by delta t, because delta x will be negative when you move a little bit to the right. So the velocity at the point A will be negative for the object 1. For the object 2, the velocity is positive and constant because it's a rectilinear line. And for the object C, for the object 3, the velocity at the point A is positive. So they have same position at the point A, different velocity at the point A. At the point B, it happened exactly the same thing. But look, the velocity at the point V of the object 3 look like it's going to be 0. 0 because the slope will be 0. So the object 3 starts at the position A with a positive velocity, maybe 10 meters per second. As he's moving, the velocity decreases 10, 9, 8, 2, 8, 7, 5, 3, and 0. So the velocity starts positive and ended 0. For the object 2, the velocity starts at the slope. The slope is maybe 10 meters per second and is constant slope. And at the point B, the velocity is 10 meters per second. For the object 1, the red one, it starts with negative velocity, negative slope. Let's say minus 10 meters per second. As he's traveling, the velocity is minus 10. It seems to me that now the velocity here is going to be 0. You see, it's horizontal. So it changed the velocity from minus 10 to 0 here. Here, at some point here, the slope is 0. So from minus 10, minus 9, minus 8, minus 3, minus 4, minus 2, minus 1, 0. And now the velocity, it goes to be positive. Plus 1, plus 2, plus 3, plus 4, plus 5. And when it arrives, maybe he arrives at positive velocity, maybe 10 meters per second. So the difference is the point A have the same position, point B the same position for the three objects, different velocity. And what about the acceleration? Oh, this is a question about the change in the slope in this graph. The slope is the velocity, and the change in the slope is the acceleration. This is more difficult. So you maybe read what I wrote here. So you read it carefully, and you'll comment me if if it makes sense for you. So let me move this. Oh, let me move this a little bit, and let me move also this. Okay, this is what I wrote. It's the same thing that I said. Analyze carefully, and you will realize everything. Now we go to problem 50. It's the same logic that we are going to use, but we have to pay attention what graph they present us. Please read the problem for a few seconds, stop the video, come back. Well, now that you came back, what happened in this graph? In this graph, at the point A, the velocity v sub A is the same one for the three objects. At the point V, the velocity v sub B is the same one from the three objects. But there is a difference. The velocity for the object 1 at the beginning is going decreasing and decreasing a little bit, maybe constant, and suddenly he will go up the velocity. So that means that in this area, the acceleration is very big for the body 1 because he performed a change in velocity in very elapsed time. So the acceleration for this body is almost zero, so there is no change in the velocity in this area, and suddenly accelerate. Let's go to analyze the body 2. The body 2 is a rectilinear line, so the velocity is changing. It's being bigger and bigger, but it's changing at a constant rate. So the acceleration is positive and constant. So the object 2 have a positive acceleration and constant, while the object 1, the acceleration is not constant. At the beginning, the acceleration is 0 and suddenly increase the acceleration. For the object 3, I leave you to think. How will be the velocity? Well, the velocity will be increasing. So increasing, and the velocity is the slope of this graph. And the slope is something like this at this point, Okay, and at this point the slope is something like this. So the slope of being positive and big to positive and smaller. So maybe the slope, that is the acceleration in this interpretation of velocity versus time, the slope means delta v divided by delta t, and is the acceleration. So the slope is very big here and decrease. So it arrives almost with a slope 0. You see, there is no slope at the point B. Well, think about it, and we continue for the next problem. The next problem say, please always pay attention to what graph they show you. This is position versus time. So what I see is that the object is initially at this position, later on his father, later on the position increased, later on the position increased, later on the position arrived to a maximum far away from the 0, and now he's approaching to the 0, So the object was here, later on was here, later on was here, later on was here, and after that he come back. So his velocity at the beginning, in the first half of the trip, his velocity is something like going up. And later on the velocity is going downwards, coming back to the 0. So let's go to answer the question that he's asking. Does the object ever reverse his direction of motion? Yes, at this point, exactly at this point, he is at the maximum distance. His velocity is 0 because the slope is 0, and he's coming back now later on, so he's reversing. So at this point, he's reversing. Second question, does the object ever return to his starting point? Of course, he starts at this point, he started at this point and he come back to the point 0. So he repeat this point, but at different times, of course. C. Is the object speed ever 0? Yes, the speed is 0 at this point. At this point, the slope is 0, so the speed is 0, or the velocity is 0. If so, where? Well, here, at this point, at this time t. At this time t, when he is at the maximum position far away from O, does the object have any acceleration? Oh, this is a good question. The velocity is the slope. So, is the slope here changing? Here the slope is positive. Here the slope is 0, so the slope is changing. So maybe the slope here is 100. Maybe the slope here is 0. Perfect. Is the slope changing? The slope is the measure of the velocity. So V initial was 100. V final is 0. Is the velocity changing? Yes, because the slope is changing. So what is the measure of the acceleration? The measure of the average acceleration is the change in velocity divided by the change in time. The change in velocity is 0 minus 100. 0 minus 100 divided by the change in time that is here. This change in time. This change in time. In these 2 points happen the thing. So the change in time is always positive, no problem. So now the acceleration is positive or negative? The acceleration is negative. Is negative for sure. 0 minus 100 is negative, and delta t is positive. So a curve in the space x of t that does like this have acceleration negative, and a curve in the space-time xt that does like this have acceleration positive. Okay, so if it goes like this, the acceleration will be positive, and the velocity is the slope. The slope, the measure of the slope is the velocity. The problem is solved. Next one, figure, please stop the video and read the problem. So, to answer this question, first of all, pay attention what graph they are showing you. They are showing you the graph of velocity versus time. So this is velocity. This is the velocity that is increasing all the time. So the velocity is increasing, well, it doesn't, I don't have more information about what it will do later than this time t, but it doesn't matter. Let's go to answer the question. The jogger speed is increasing. It's true. It's increasing. At the beginning was this velocity, always increase, always increase, always increase, always increase, always increase. So this is true, so I will mark like true. The jogger speed is decreasing. No, this is not true. The jogger acceleration is increasing. Wow. The acceleration of a body that is constant is when the velocity versus time is a rectilinear line. If the velocity versus time is a rectilinear line, means that the acceleration is constant. Is this graph velocity versus time a rectilinear line? No. So the jogger acceleration, so the acceleration is changing. But now we have to see if it's changing in a positive way or in a negative way. Well, the acceleration is the change in the velocity per unit of time. I see that the change in the velocity is this thing. I see that the change in the velocity is this thing, change in v. So the change in the velocity is positive. So the acceleration is positive. So the velocity is always increasing in this graph, in the information that they are giving to me. Always is bigger. You see this thing is bigger and bigger and bigger, and the change in velocity per unit of time is positive. But the acceleration is positive, but is increasing or decreasing? And I see that the change in the velocity is always smaller. So if the change in the velocity is always smaller, the acceleration is decreasing. So the jogger acceleration is decreasing. This is the correct answer. Let's go to the next question. Please read the questions, stop the video, and come back. Okay, so now we are going to answer these questions. So this is the graph. As I say always, you pay attention to the graph. It's v versus t. So the change in v is acceleration. There is no here information about the position, but you know that if the graph of a rectilinear line is, if the graph of BT is a rectilinear line, the position change like a parabola because it's a motion with constant acceleration. Okay. So now we are going to answer the questions. This is the velocity. Velocity is increasing, positive and increasing, very big, the highest velocity at the point V. Later on is decreasing. So the velocity is never negative. So the object is always advancing, is always performing. V by delta t is always positive. So he's always advancing, going far and far and far and far. He never returns. So at the point C, the first question, is true that at the point C the cat has returned to the place where it started? No, how can he start if he's never come back? The velocity is always positive. No, this is wrong. No. As option B, the cat speed is 0 at point A and C. At point A and C. I don't see the point A, but I see the point C. Where is the point A? Well, this is partially true. If the point A is this one, it's completely true. Maybe it's true. C, the cat velocity is 0 at point B. Well, at point B, the cat velocity is this amount. So it's not 0. So this is wrong. C is wrong. And D, the cat reversed the direction of his velocity at point B. No, it's not true. The cat is going with this velocity, maybe 10 meters per second, 20 meters per second, 30 meters per second, 50 meters per second, and now 40 meters per second, but he's always advancing in the direction that we agree he's moving. So the velocity, the cat never reverses its direction of the velocity, is always positive. So the only option that I see could be true is option B. Let's go to the next question. Next question. Please read it carefully and wait for the solution. Try to solve by yourself. So in this question, I see the graph of velocity versus time. So pay attention that the graph that they present you is the graph of velocity versus time. And what I see is that the velocity is negative. When the time passes, the velocity is also negative but smaller. Also negative, not smaller, bigger in magnitude. Later on, the velocity is 0. Now the velocity is positive. Now the velocity is positive. Now the velocity is positive and increasing. So the velocity is always increasing. It starts maybe with velocity vi equal maybe minus 100 meters per second. When it's here, and when it's here is minus 90, minus 80, 0, plus 10, plus 20, plus whatever. So let's go to answer the question. A, his acceleration is increasing. No, the graph of this graph means that the change in the velocity are change in velocity per unit of time is constant because it's a rectilinear line. So his acceleration is not increasing. His speed is decreasing from A to B and increasing from B to C. No, his speed is always increasing from A to B. It is moving to the right between A and C. Well, the velocity is negative first, so he's moving to the left, and when he arrived to the point V, the velocity is 0, he reversed, and now the velocity is positive. So he was moving initially with a high velocity, negative velocity, going to the left. Later on, the velocity becomes 0 at point B. And later on, at this point T, maybe this point T, his velocity is positive. Positive going to the right. So, what question I was reading, it is moving to the right between A and C. No. Between A and B is moving to the left. And between B and C, the point C, this point, is moving to the right. It is moving to the left between A and B and to the right between B and C. So this is the correct answer, D. Okay, let's go to next question. Please read carefully, try to solve it by yourself, and come back. So for this problem, you need only to read the graph. It says that you have to find what is the person displacement during each of the following time. Well, I will do only one. At t equal 1, t equal 1 seconds, and t equal 10 seconds. And you do all this thing, and I'll do the b. Okay, in t equal 1, the object is at the position 1 meter. So t equal 1, x1 equal 1 meter. At t equal 10, the object is at the position 6 meters. So what is the average velocity? What is the displacement? The displacement is x2 minus x1. He has gone from here to here. So the displacement delta x is this one, delta x. And this one, delta x, is clearly from 1 to 6, which is 5 meters. Or equivalent, x2 minus x1, which is 1 minus, x2 6 minus 1, which is 5 meters. So the average velocity will be delta x divided by delta t. So it would be 5 divided by delta t. The time elapsed is 9 meters, 10 minus 1. So now let's go to the part B. The part B say, what distance did the person move from t equals 0 to t equals 4 seconds? Okay, from t equals 0 to t equals 4 seconds, he started at x equal 2. So he moved 2 meters. Later on, he moved 1 meter again, when t equals 3 is 1 meter. So the distance is 3 meters. And he come back at t equal 4, he come back to 0. So he has walked 2, 3, 4 meters. So that's the distance. It's different than the displacement. The displacement between this point and this point is only -2. But the distance that he traveled is 4 meters and is always positive. So let's go to write it. Between t equals 0 and t equals 4, the displacement delta x equal -2 meters. And the distance traveled is 4 meters. He walked, how many steps he walked? He walked from these 2 meters, and I'm at t equal 2 seconds. This meter, it comes 3 meters, and I'm at t equal 3 seconds, and he walked again, another meter, so he walked 4 meters in 4 seconds. So if you want to find what is the distance, is already found. You do the problem for the other case. Okay, now read the problem, come back soon, and try to solve it by yourself. So this problem is just to interpret the graph. So you have to pay attention that the graph say x as a function of t. So the point A is the origin, I suppose. The point B is this point. The point C is happening at the time t equal 5 seconds, x equal 9. So the problem say find the average velocity between A and B, or between A and B, between 0 and B, between A and B, between A and B, between A and B. The position initial is 0, and at the point V, the final position is 3. And the initial position happened at time t1 equals 0, and the final position happened at t2 equal 1. So the change in the position is 3 times, and the change in time is 1 second. So the average velocity is 3 divided by 1 meters per second, and the problem is done. From point V to C, the change in position is from the 3 to the 9. 3 to the 9, the change in position is 6. Delta x equals 6 meters. And delta t, the change in time is from 1 to 5. 1 second to 5 seconds, 4 seconds. So the average velocity is delta x 6 divided by 4. So meters per second. If you prefer, 3 divided by 2 meters per second. And from A to C, you'll do it. You know how to do it. Question B. For intervals in part A, would the average speed be less than, equal, or greater than the value you found in the part A? Explain your reasoning. What is asking? For the interval in part A, for every interval, would the average speed be less, equal, or greater than the value you found in the part? I don't understand what it's asking. You try to understand. Okay, go to the next question. Please read carefully this question, try to answer, try to do it by yourself, and come back. Well, this problem is the same like the other one, only the graph is different. So the graph is different, it means that because the velocity is the slope, the velocity here is positive. Now the velocity becomes positive and bigger. And here the velocity is 0. So the velocity is v at the beginning, at the beginning. Later on at t equal to second, it has decreased a little bit, and decrease at the point V, the velocity, that is the slope, becomes 0. And later on, the velocity starts to be negative and negative. Okay, this is the graph of this is the graph of a position versus time, and you know how to do. the change in position divided by the change in time, and this is the average velocity. Well, indeed, the velocity is not exactly like this. The velocity at t equals 0 is some value b. That is the slope. Now the slope becomes bigger and bigger. And here at this point is the maximum slope. Later on, the slope starts to decrease, and becomes 0. So the graph of velocity of this function is more or less v as a function of t is more or less like this. Okay, and now the velocity in this graph, the slope become negative, so it will be negative slope. Later on will be the maximum slope. Later on decrease, and at the point C, the velocity is negative, and it has some value, a smaller value. So the function will do like this, something like this, smaller. Of course, I cannot continue doing because I don't know what will be after C. That's all. Let's go. Please read the following question and try to solve by yourself. This problem is about a boulder that is rolling through a hill, and it says that the equation of motion for the position of the boulder is here, x versus t. So at t equal 1 second, I see this is 2.5, so I may see 1.25, half of 2.5. At t equal 2, his position is between 2.5 and 5. Between 2.5 will be like 3.75. Maybe I have to correct here and writing down here 3.75. Maybe I don't see clearly what is the position 3.75. So what it says, find the average velocity for each interval. So if t1 is 0 and t2 is 1 second, delta t is 1 second, if x1 is 0 and x2 at time t2 equal 1 second is 125, I see more or less 125, half of this, so delta t will be 1, delta x will be 125. This is the displacement of the object in this interval of time, and the velocity is delta x divided by delta t. So in this case, delta x is 125, delta t is 1, so I will obtain the average velocity of 125 meters per second. So I can do the same thing for t equal 2, from t equals 0 to t equal 2, so t equals 0, the position is 0. From t2 equal 2, I think that the position is 3.75, so the displacement will be not 4, will be 3.75, and the velocity will be 3.75 divided by the time elapsed, and the time elapsed in this case is 2 seconds. So the velocity will be not 2 meters, it will be 1 1.50 is 3. 0.75 divided by 2 is 1.35. So the velocity will be 3.75 divided by 2, which is 1.80, something like this, 1.85, I think. Okay, you calculate. So what this, and you do the same thing between t equals 0 and t equals 3, and the displacement is IC 8 meters, x2 at t equals 3 is almost 8 meters. I think it will go to the 8. So if you do, so what the problem it wants to ask you, that if you calculate the average velocity between different points, you will obtain different results. If you calculate between this point and this point, the average velocity is smaller than if you calculate between these 2 points, because now the slope is bigger than in the previous case. If you calculate between 0 and 3, the slope will be even bigger than before. So the average velocity will increase. This is, I think, what it wants to show you. Now, read the question, read the problem, think about the possible answer, and come back. Okay, what the problem is asking me is, in each case, can you draw the graph of the velocity? So let's go to graph the graph of the velocity for this case, for the first case. So it's this one. This one, the first case. The first case, this one. So the velocity, the position, the delta x is increasing at constant slope. Delta x divided by delta t is constant because it's the motion of a rectilinear line maintains its slope constant. So the graph of velocity versus t must be something like this, v. And what is this value? This value is the value of delta x divided by delta t. Perfect. Let's go to do the next one. The next one. What will be the graph of velocity time, bt? I see that the position never change. If the position never change, x1 equal x2, t1, t2, the position never change, so x2 minus x1 is 0. So delta x is 0. Delta t is never 0. Delta t is t2 minus t1, whatever it is. But the average velocity, v average, is delta x divided by delta t. But delta x is 0. And 0 divided by something, different than 0, of course, is 0. So the velocity will be this graph, 0, for any time. Let's go to the third one. The third one is this one. Let's go to solve it here. So this velocity is constant because the velocity is the slope of the graph. And in this case, the slope is negative. So what will be the graph of this third x of t? What will be the graph of v versus t? Well, it will be something like this. V negative, because the slope is constant and have the value negative. So this solves the problem. Let's go to the next one. This one, you think about it. Oh, this is instantaneous velocity. So instantaneous velocity is when you calculate the average velocity, but you make a process that is called limit process, where you, instead of calculating delta x divided by delta t, you calculate this, but when delta t goes almost to zero, never is zero, goes it approach to zero, so the change in delta t, this change in delta t is very, very small, between two times that are very next one to each other. So in this thing, the velocity is always the slope. So the velocity is the slope in this graph. So let's go to erase here. So now let's go to read. A physics professor leaves house after 5 minutes. So I already read. So at question A, if they give you the graph of x versus t, at which of the points her velocity is zero? The velocity is the slope in the graph x of t. So I will look for a point that have a slope zero. I think this is the point. This is the point. More or less, this is the point that has slope zero. So at this point, his velocity is zero. It means that he's not moving in this direction and he's not moving down. He's just instantaneously velocity zero. B, constant and positive velocity. Well, I see here I see a constant velocity because the graph is a rectilinear line. This one I see a curve, so it's not constant velocity. So constant and positive velocity is here on this segment. Or in the point 1 also is constant. Or not in the point 1, you cannot say if it's constant and positive. You can say in an interval of times. From 0 to 1, the velocity is constant. Constant and negative. Constant and negative, I see this rectilinear line. So from t equals 6, I think, to t equals 8, the velocity is constant and negative. Increasing in magnitude. Increasing in magnitude what? The velocity or the position? That didn't say. Well, if it's the velocity is the slope. And the slope at 1 has certain slope. At 2, the slope is bigger. So it's increasing here. From 1 to 2, it's increasing. From 2 to 3, the slope is like this, but in 2 is like this. So the slope in 3 is bigger. So it's always increasing from here to here. Now the slope decreases, so from 3 to 4, the slope decreases, so the velocity decreases. And that's all, increasing. Decreasing in magnitude. Well, from 4, that the velocity is 0, to t equal 8, is decreasing in magnitude. Because the slope, the velocity, the slope of the graph x of t is being negative in this portion. I hope it's clear. This one, you should do it. I'm not going to try even to do it, okay? And you think about it and you do it. This one is an easy one also. I think you can do it. For sure you can do it. So in this graph, they give you a graph, well, you read the problem, you think about it, and you come back. Now that you have came back, let me solve this problem. This problem say that they give you a graph of velocity. The velocity is constant in this from 0 to 5, I think, is constant. From 5 to 10, the velocity is increasing, so the acceleration is positive. And from this point, that is almost t equal 9 to equal 13, the velocity is decreasing all the time, so the acceleration is negative. So find the instantaneous acceleration at time t equals 3 seconds. t equals 3 seconds, I see that around t equals 3 seconds, this is the concept of acceleration, around t equals 3 seconds, this is the 3, around for 4, but you put it, you imagine very near. And for 2, the velocity have not changed. So the acceleration is the change in velocity per unit of time. And the instantaneous acceleration, instantaneous, is a process when you take the limit when delta t of delta v divided by delta t. And this is equivalent as seeing the point 3 as you see very near the point 3. Let's say in an interval of 0.5 seconds. But indeed, you take this 0.5 seconds from 3 to 3.5, and from 2 to from 2 to 3 is 1 second, and from 3 to 4 is, you take an interval of 1 second, but you make the interval, this is the 3, this is the 4, this is the 2, you make this interval, and you make another interval of time, delta t, very, very small. So at the end, you are going to watch around the point 3. And around the point 3, what I see is that the velocity never change. So the acceleration is the change in velocity per unit of time. So the instantaneous acceleration will be 0. Okay, at t equals 7, t equals 7 is something like this. So you will see around the 0.7, very near the 0.7. Time t a little bit bigger than 7, let's say 7.1, and map time t a little smaller than 7, let's say 6.9. But even you make this lapse time to goes almost to 0, that means that you are watching at the time t equals 7, but the interval of time may be 7, and here is 7.0001, and here is 6.999. So you are watching very near the 7. So at the 7, what I see is that the velocity is changing. So there is a change in the velocity. So, but the velocity, the graph of the velocity is a rectilinear line. So the acceleration is constant because the velocity grows as a constant rate. And what will be the acceleration? Well, to find the acceleration, maybe I use a comfortable place to find it. Maybe I can maybe I can do it from here. That 6 is 22.5, and maybe you use this point 8. So the acceleration is the change in velocity per unit of time. V final, I see 35. V initial at t equal 8, V final, I see 35. T equals 6, you will say, but you told us to see in a very narrow interval of the 7. Okay, yes, but because it's a rectilinear line, I can extend my interval of time because the slope is constant. So whatever I do, I will find the same slope. So B final is 35 at t equal 8 minus 6, and at t equals 6 I see 22.5. So the average acceleration A will be 35 minus 22. 22 is 8 is 13, 12.5, I think, 12.5 divided by 2. Like 6.25 meters per second square. And this is the acceleration, 6.25 meters per second square. I don't know if I made the calculation correctly, but you can You can do it. T equals 7, and at t equal 11, t equal 11 is here. You do the same thing, and you will find a negative acceleration. The change in velocity will be negative. Let's go to the next question. Now, the graph that they give you is velocity versus time, and you need to plug in to sketch a qualitative graph of the acceleration. The acceleration is the slope. So for A, I will draw something like this. A as a versus of time, I will draw constant acceleration. And what is this value? The slope. And what is the slope? The slope is this divided by this. This is the slope. Okay. For this graph, I see almost, for the V, I see almost a parabola. So I would say that the graph of acceleration versus time is something, because the slope is changing in the graph B. You see, the slope is the acceleration. The acceleration is being bigger and bigger and bigger, so the acceleration is going to be maybe something that is increasing, maybe a rectilinear line. Maybe a rectilinear line. Now, for the graph C, the velocity decrease, but it decreases at a constant rate because the graph is a rectilinear line. So the graph will be, of the acceleration versus time, will be something negative, A0, negative and constant. While in the other graph, D, the slope of the graph, that is the acceleration, the slope goes from being positive and big to being positive and smaller. So the graph will start here and will go to be smaller, smaller, smaller. So the graph starts with certain value. As time passes, the acceleration decrease, and when you are here at this point, the acceleration becomes 0. So these are the graph of acceleration versus time. Let's go to the next question. Okay, read this problem and do it by yourself. I'm not going to do it because I think that you are already prepared to do this problem.